Hello, this is Vincent Burnett of Wonder Code Studios. Modern video games often present players with vast virtual worlds for the player to explore. These vast virtual worlds require a vast amount of digital content. One way to produce all this content is by getting a collection of digital artists to produce that content. This unfortunately requires a lot of time and a lot of resources, but it does provide direct control of the entire world. Another method are procedural methods. Procedural content generation produces the content through algorithms. They're very efficient, don't require much time or resources, but they provide limited control over the content provided to the developer, and often don't produce the content exactly that the developer wants. Now, in most games have certain points of interest where the developer needs total control over that area. These would be like quest centers or villages or something like that. Now, other parts of that game, the developer doesn't have to control the position of every blade of grass or the position of every tree and such. And those areas would be ripe for procedural content generation. So the best of both worlds would be to get a system that would be able to allow most of the world to be produced procedurally, whereas allow that content to be edited and added to and by direct manual methods. So in this set of videos, I'm going to be exploring procedural content generation in relation to terrain and foliage. Okay, so let's look at the first very basic method of procedural terrain surfacing. Okay, here we have a procedurally generated terrain. The geometry is created by multifractal algorithms, and the surfacing is basically just using the color is determined by the elevation. Okay, and then we use a constant normal map. Now, if you look at the pixel shader here, here's the pixel node network. It produces the pixel shader. Now, text coordinate 0 contains the world position. The Y component, which is the elevation, it's basically scaled and multiplied into the range from 0 to 1. Okay? By these range map and multiply 1D nodes. And then it's put into this gradient node. The gradient nodes takes in a float and outputs a color. You can see at low elevation, you get green, then you get brown, you get orange, and then you get yellow. You get white, sorry, for like snow. And you can see that's what you're having here. Okay, now this doesn't look bad, but it's not really what you'd see in reality. In nature, it doesn't have a detail of the variety that a normal terrain system would provide. So let's go on and consider more advanced procedural terrain systems in the next video. Thank you. Bye.